Hi everyone, welcome to chapter 7 of Unity training for Theatre. We're just covering all the basics of how to make Unity accessible to people who want to make visualizations in theatre or to make their own animation apps for VR, AI, anything like that in the future. We're going to talk about optimizing the scene in this lesson. It's very simple. I'm going to show you one button and it's all you really need to know. It's this one here. It's called stats. Just gives you lots of information about what's happening inside your scene. The main one you want to look for is the FPS, which is here. And at the moment we're running at 250 frames per second, which seems a bit wrong, but let's actually hit play and see what it really says is happening in our scene. Now I'm running a 3090 graphics card here, which is really high. And 130 frames per second is absolutely fine. You want to be running at more than 25 because that's TV. So if you're just looking at a monitor, 25 frames per second is really the minimum. You can notice a difference up to 50 frames per second. And if you're using VR, there's a whole debate out about this, but it typically needs to be more than 60 to 90 frames per second, so you don't get any latency. I've actually run visualizations at 5 to 10 frames per second, and it's not been a problem because the scene runs fast enough that you can actually see what's going on, but it's just a little bit difficult because you're watching a lot of stepping in between. You've got to remember that your animation data has probably come in lower than that, and if you're running videos, the videos before being encoded to run at 25, 30 or 50 hertz. So there's no point having a really high FPS. There is such a thing as draw calls. I honestly can't remember where I'll find that now. It's in here somewhere. But you want to find a draw call, if you want to research that, that's about what's actually happening inside the engine, so you can really understand how it's pulling processing power based on what you're looking at. It's really the true value of what is the pressure on the game that you're making. To be honest, if you're getting your frame rate that low that you're putting that many draw calls, I don't know what you're doing, but you're probably a massive 3D model, or maybe your textures are too big. So go and have a look at all of your textures and your materials and make sure that they're using really efficiently made JPEGs and PNGs that aren't 15,000 pixels wide to make sure they're really optimized. A note on optimization actually for textures is try to use square value texture maps. So you hear me talk about 512 by 512 or 1024 by 1024. There's a reason for it being square. If you go to 1025, it ends up processing a whole nother texture square in the space. So keeping it all in 1024 by 1024 means it's only rendering that many bits. If you do that one pixel that goes over the edge, suddenly you're looking at rendering a massive extra tile that's not doing anything. It's just going to be black or white or clear. So we don't really want that. We want to keep everything into those squares. If you've got an awkward shape, like I had a video that was 1920 by 1080, that's kind of the exception. I mean, just accept that it's going to draw more processing than it's really optimized to do. But proper game development, you would map everything with a UV map onto squares. You'd never go into sort of rectangular shapes. So something to think about when you're making things. Your 3D models, I think as a rule, you shouldn't use more than 500,000 polygons in your whole model. My game engine here, with the decent graphics card I've got, I'd probably have several million and it wouldn't be a problem. There used to be a rule I had, and it's about 10 years old now to be fair, so I probably should update myself, but when I was working with WYSIWYG and Vision, ESP Vision as 3D visualization programs for the theatre, 200,000 polygons was really your limit. That's what the software could handle because it was running on, at the time, 8-bit software. So now that we've got much more advanced computers, you can handle a lot more detail. But really, if you're modelling something that's over 500,000 polygons, then it's going to be really difficult to work with anyway. Even if it runs fine in the engine, you're just going to find it fiddly. There's going to be bits in there that you can't grab. There's going to be details that are just lost, and you've got to put materials on them all, and they might not be captured as part of an animation. Just clean it all up, make it nice and neat. Just what do you need to see? You don't need all the bolts, you don't need all the braces and everything. You just need a stick. Use a plane with an alpha map instead of a cut cloth with millions of polygons on it. Just try to get it efficient. So they're the two best ways to optimize. If that FPS is running really low, think about your polygon count and your 3D modeling technique, and think about your textures that you loaded in. Check those before anything else. And obviously, I hope it goes without saying, if you've got 400 real-time lights, that is going to slow it down. So just keep an eye on your lights as well, make them quite efficient. And that's the end of optimization. In the next scene, we're going to have a quick look at the C# script.